are the Cure Girls. We are 7 women from across the world living with a spinal cord injury. We were formed by Loredana Longo because we all decided that there wasn't a group of people with a spinal cord injury that truly represented us. Every year around the world, between 250,000 and 500,000 people suffer with a spinal cord injury. Over the years, we've promoted fundraising initiatives by collaborating with various associative and international organisations, also raising awareness wherever possible. We want to raise awareness and to tell everyone what it's really like living with a spinal cord injury and not sugarcoat it. We want to highlight the real problems that we face with our day-to-day living, not for pity or sympathy, but to show the world that there is an urgency for a cure for paralysis. Altogether, we try to support research projects for the cure of chronic spinal injuries. A cure is not merely a dream, it is a lifetime necessity for us and 3 million others around the world. The most cases of spinal cord injuries are due to preventable causes such as road traffic accidents, falls or violence. People with a spinal cord injury are 2 to 5 times more likely to die prematurely than people without a spinal cord injury. Now, there isn't a cure for chronic spinal injuries, but the numerous scientific discoveries have shown that regeneration of the nervous tissue is possible. The Cure Girls are convinced that it is reasonable to think that it is no longer a matter to wait for a cure to come along, but it's important for us to act because this should be done as soon as possible. If you want to support the Cure Girls, follow us and support our initiatives. Chronic spinal cord injury must become curable. A few weeks ago, we were at King's College in London to meet Alison Wadley, who is Marketing and Communications Manager at Spinal Research, and Professor Elizabeth Bradbury.
There are more than 2.5 million people worldwide living with paralysis caused by spinal cord injury. And spinal cord injury is more than not just being able to walk. It affects people in so many different ways, their bodily functions, such as the feeling, touch, sensation, bladder and bowel control, blood pressure, temperature control. And all of these can have a devastating effect on people's lives. At Spinal Research, we're the UK's leading organisation funding research to find effective treatments for spinal cord injury. Chondroitinase is by far the most potential experimental treatment for spinal cord injury. We worked hard to understand and to find out more about chondroitinase, and we are absolutely determined to take these to the clinic. Research into spinal cord injury is really underfunded. We need to raise awareness that there are treatments that could be available, and we need to raise funds. So we need to raise awareness. We rely purely on our supporters to fund the research that is happening in the UK and worldwide.
Can you explain us the difference between acute and chronic spinal cord injury?
Okay, so acute injury is immediately after the trauma of a spinal cord injury and the first few hours to days after that injury. And then the chronic injury, what happens after a spinal cord injury, there's lots of reactive changes in the tissue, and these happen over the next few days and weeks and even months after the injury, and then you end up with the chronic situation. So that's when we've got an established scar tissue, there's been an inflammatory response, and the tissue has and the area of damage has expanded, and you've got lots of cell loss, and that's what we call the chronic stage, when everything is stabilized. So the acute is immediately after injury in the first few days, and the chronic is after all the other reactive changes after the acute injury has happened, and you're with a chronic established injury.
Is it correct to say that the therapies to cure chronic spinal cord injury will probably be different from the therapies to cure acute spinal cord injury?
Some of them could be the same, but the thing with an acute injury, the idea of an acute injury intervention is to get in there quick and stop some of the secondary damage that happens after an injury. So this will be what we call neuroprotective therapies that prevent more nerve cells dying, stop some of the inflammation and the damage getting worse. So those kind of therapies would only really work in the acute stage. The things we're looking at for chronic therapies are more regenerative type therapies, and they could work either in the acute or chronic stage. But in the chronic stage, when we've got this established injury, we then want to use therapies that kind of break down some of this chronic scar tissue and enhance what we call neuroplasticity, which allows nerve cells that are remaining to try and compensate for some of the function that's lost, make new connections and strengthen the connections of the established nerve fibers that are there. So they are quite different, the acute and chronic type of treatments that we would use, yes. For many years in my lab, we've been focused on trying to break down some of the scar tissue that forms at the injury site. And the scar is very important because it happens immediately after the injury. You get cells that react and seal in the injury, and it's very important to have this scar tissue. But unlike a scar that's on your skin, for instance, that heals up and resolves, the scar on the spinal cord stays there, and then it prevents, it's kind of a wall of cells that prevent new nerve cells growing. But not only that, the matrix of the scar has inhibitory molecules that stops new growth. So what we try and do with our chondroitinase enzyme is break down some of these inhibitory molecules, allow everything to be more plastic and allow new growth to occur. So originally we originally started with using the bacterial enzyme chondroitinase and injecting it into the spinal cord, and that worked very well with the injury models we were using at the time. But when we've more recently moved to clinically relevant injuries that really mimic the trauma that you see in a human spinal cord injury that develops and evolves over time, with injections of the bacterial enzyme weren't really very effective. So we've now started working with a gene therapy approach. So this gives much more long-term and stabilized treatment of the gene, because the cells, what we do with the gene therapy is we make a viral vector that has a mammalian form of the chondroitinase gene inside it. We inject that into the spinal cord, so the spinal cord cells themselves can now have the chondroitinase gene, and then you can treat lots of areas of the spinal cord because the cells themselves are producing chondroitinase. And that way we can get a really long continuous therapy and a treatment in the spinal cord, and that's really, really required for these chronic traumatic injuries. And then we can enhance some of the plasticity, enhance the function of the spared nerve fibers that are still remaining in the spinal cord. And more recently, we've advanced the gene therapy even further because we're very excited about the results we saw with our first gene therapy approach. But now what we found is that we've looked a whole year after injecting just a single microliter of this gene therapy, we've still got active chondroitinase in the spinal cord. And eventually, to translate this to the clinic, we want to be able to say we can turn this therapy off, because potentially long-term treatment with chondroitinase could have some bad effects, or you could lead to increased pain if you've got lots of neuroplasticity. So we're now working with an inducible chondroitinase gene therapy. So we give the gene therapy, it's got a special regulated element that's only turned on when you give an antibiotic. So we treat the experimental animals with an antibiotic that switches the gene on, and then when we remove that from the drinking water, the gene should be switched off. And we just got some really recent results that we've shown if you just give the doxycycline antibiotic just for 2 weeks, it's not effective enough to get this really strong recovery in hand function. But if we give the treatment for a long term, so we've given it to 8 weeks after a cervical level contusion injury, we've got really nice hand function, and this is fine control function, reaching movements where the animals have to pick up sugar pellets. So this is really an important function that spinal injury patients want to get back, control of hand and digit function. So we think this is a really promising treatment. And the fact that we can switch the gene on and off, there's still lots of issues to resolve, like we need to be sure we're completely turning it off and there's not any leakiness, so we might have to modify the gene therapy further before we can be sure of that. But at the moment it's looking very, very promising. We can switch this gene on, give it for a period of 2 months, and we can get really nice recovery of really skilled hand and finger function with this therapy. Well, so far all of our studies have given the gene therapy acutely, so immediately after the injury, but we've just received funding from the Spinal Research Trust to now apply this to a chronic injury. So we're going to, the injury will be well established, so in the chronic phase with an established scar tissue, established cavitation and inflammation events when they're well established and the injury is stable. We're then going to give the gene therapy and then we'll be looking. This is something really important that we need to know. Is it going to be effective in a chronic injury? But we think there is preliminary data that it is going to be effective, but because we think the main effect of chondroitinase is enhancing the capacity of spared systems to take over functions that are lost and to make new connections or to restore or to strengthen the connections that are there. And there's other work from in the US that's shown giving chondroitinase a whole year after injury can restore some breathing functions in their animal models, so we're quite confident that giving it in a chronic stage might produce some really exciting results with the upper limb function and the hand function. But this is something we're about to find out in our next studies.
Are you optimistic about the possibility for people like us to walk again one day?
Well, I think it's a very optimistic time in our field because we are now beginning to understand why the tissue doesn't repair, why there is no recovery after spinal cord injury. And we've identified these new targets and we know that things like the scar is preventing nerve growth. And we're making these new advances with our current therapies, and in particular the chondroitinase gene therapy is looking very, very promising. It's still a long way to go and there's a lot of incremental steps to get there, but I am optimistic for the future that people will be able to get some function back after a spinal cord injury with these kind of experimental therapies that are emerging right now.